Relations and functions, section 8.1. A relation is any pairing of x and y values. So often when we think of this, we think of the coordinate point x, y. X is first, y is second. So any pairing of x and y values creates a relation. Basically, everything we work with in this chapter is going to involve some form of a relation. Now, there's specific names for each of our x's and each of our y's. And the first one is called the domain, and this is our set of all x values. So all of the x values that we come up with are known as our domain, and these are considered our input. All of the y values then, a set of all y values, are our range, and this is our output. So we're going to be working in this chapter, it says our title is Relations and Functions. We're going to be working with functions on a broader scale, equations. And what you can think of is that before we worked with just equations like 3x plus 2 equals 10. Now we're going to be having things with x and y in it. So maybe 3x plus 2y equals 10. So we're going to have a whole bunch of x's, a whole bunch of y's, and all of our x's, like we said, are domain, all of our y's are the range. So you can almost think of it like a machine, okay? We have two parts to our machine. Inside of our machine are where all of our x values are going to go. This is our domain. Our domain goes into the machine, all of our input values. We put them into the machine. When they're in the machine, these x values go through the process, through the workings of the machine, and then what spits out are our y values, known as our range or our output. Okay, and that's essentially what we're going to be doing throughout this chapter. We're going to be inputting x values, domain values, to determine what our output, our y values are. Okay, so let's start out first just by getting a good grasp of domain and range. Example 1 says identify the domain and range of each of the relations below. Okay, so domain are all of our x values. So we see here age, x, and years are all listed straight across. So my domain is the set 1, 2, 3, 4, and 5. Those are the points that we have. My range are the set of all the y values, and they note here that these are our y's. So my range is 23, 36, 47, 61, 73. Now in this case they're all in numerical order, but had they not been, we would want to make sure when we write it out that we do put them in numerical order. Okay, let's try letter B. Our domain, set of all the x values. So 2, 4, 5. Now in this case we notice we have two 5s. If we're writing out our domain, we just have to write them once. We don't want to write it twice. So 2, 4, 5, and then 7, and then close the bracket. So 2, 4, 5, 7 for our domain. Our range is 32, 59, 65, 69, and 96. Those are all of our range values. Notice in the directions, they use some vocabulary right off the bat. Identify the domain, all the x's, in the range, all the y's, in each of the relations, pairing of x and y below. So we just did that. We already applied 3 of our vocabulary words. So here's a U-try. We want to identify the domain and the range of these values. So my domain are going to be all the x values, and we want to remember that an ordered pair or coordinate point goes x, y. It's alphabetical if that helps you remember which is first. So my x's are 0, 2, 3, and 5. They're already in numerical order, so I don't need to put them in any kind of change them around at all. 0, 2, 3, 5. We're perfect. My range then, we'll use a different color. My range is going to be 1, 4, 7, and 4. Here we have a repeat, but like we saw above, we don't repeat it, we just write it once. So 1, 4, 7. And that's it. Okay, part B. Our domain are all of the x values, so it's going to be -1, -3, 6, and -1. If it helps you to write it out first, just straight across the way they give it to you, go ahead. I'm not going to write this -1 again, because like we said, if it repeats, we don't write it twice. But then we can write it correctly the second time. So -3, -1, and 6. And what I mean by correctly is that this is in numerical order. So that would be your final answer. Let's try the range. The range are all of our y values. So 2, -1, 0, and 4. No repeating. 2, -1, 0, and 4. And we notice that those are not in numerical order, so we go ahead and put them. -1, 0, 2, and 4. Good job, guys. All right, so let's turn the page. Whoopsies, in the way. Now we're going to look at how these relations, a set of x and y values, can be indicated using a graph, making a graph. So what we want to do is we want to plot these points, our x and our y values. We know that x is the horizontal axis, y is the vertical axis. So I'm going to plot the point -1, 1. So I go back 1, up 1. Now we did this back in chapter 1 actually, believe it or not. So we should be comfortable with plotting points. If you need a little bit of review, feel free to go and ask me for questions or to check out the beginning of the chapter when we did some coordinate points. I believe it was section 1.8. But once we plot each of these points, we can go ahead, we mark them like this. Now, they don't have letters with them. It doesn't say like point A, point B, point C. So really for our purposes in this chapter, we don't need to label each of the points we plot. We'll get too crowded on our coordinate plane. So you can just plot them. And secondly, and this is something a few people get stuck with, we don't want to go ahead and connect them because these are just random points. There's no equation that goes with them. So we don't want to connect anything. We just want to leave them the way they are. Okay? Nice job. All right, now in part B, they want us to make a mapping diagram. So I'd like you to draw in 2 rectangles. And the first one is going to represent our domain, and the second one's going to represent our range. Now what we need to do is write in the domain block all of the domain values. So it's -1, 2, 3, 3, and 4. Well, we're not going to write the 3 twice, so we'll just put -1, 2, 3, and 4. Then we're going to put all of our range values, which are 1, 0, 1, 2, and 5. So we'll have 1, 0, 2, and 5, or 0, 1, 2, 5, putting them in numerical order. Now here comes the fun part. Now to map this, essentially all we're going to do is connect the points to where they go. So the first ordered pair says -1, 1. So that means we start at -1, we're going to connect it to 1. The second ordered pair says 2, 0. So we start at 2, we connect it to 0. 3, 1, 3 connected to 1. 3, 2, 3 connected to 2. And 4, 5, 4 connected to 5. It almost looks like shoelaces, badly laced shoelaces. So if I say in class, shoelaces, that might help you trigger your memory that that's what a mapping diagram is, because we'll be looking at different graphs, so it's easy to confuse them. But I can assure you that this stuff isn't going to go away. You'll be using it for years and years and years to come. I have calculus books that have mapping diagrams in them that look just like this, and they map values from one to another, sharing the domain and range. So it's important stuff. It's excellent that we're getting a head start right now. Alrighty. Now, if you could fill in these terms with me, we're doing great so far. I want you to write in that a relation, a pairing of x and y values, is specifically a function if for each x value there is exactly, notice that's capitalized, 1 y value. That can be a little bit confusing to understand because we're just really diving into what x and y are. So what I really want you to remember here is that another way of thinking of it, aka, is that for it to be a function, okay, if we have a function, then that means our x's cannot repeat. Okay? That's really what you want to be remembering. If it's a function, that means your x's cannot repeat. And we've looked at a few above where we saw some repeating values, x or y. Now notice I didn't say anything about the y values repeating. They can kind of do whatever they want, but the x values cannot repeat. Okay? Let's try an example. Example 3. Tell whether this relation is a function. So all I'm going to do is look at my x values. 2, 4, 5, 5, 7. Do my x values repeat? Yes, I have that 5 showing up twice, so sadly this is not a function. If you want to draw a little sad face with tears, that's fine. No function. All right, let's look at part B though. 1, 2, 3, 4, 5. Woohoo! We do have a function, yes. And so none of our x's are repeating. We have a function. We'll talk more about what functions are, okay? All right, that's it for this first part. We have a little bit more to go, so if you could visit me with part 2 of section 8.1. We'll continue the rest of these notes and move on from there. So see ya in just a second with part 2.